What did I do?
Oh.
Times 2 times r. Well, r we just found as root 769. And then dr dt, negative 6 feet per second. This is feet. This is feet. This is feet. Okay. I'm going to erase the scratch work we have up here now. So I got room to actually do this. So, showing my work. dx dt, what we want, is going to equal root of 769 squared. 769, right? It's going to be feet squared now, though. So we get a half 769 feet squared minus 25 feet squared. 625 feet squared, right? And that's all going to be times 2 times the root of 769 times negative 6. What?
We're getting the negative 1/2.
To the negative half, thank you. 2 times negative 6 is negative 12 times root 769 is negative 12 root 769. Feet and feet cancel. Oh, I'm sorry, not cancel. It's going to be feet squared over seconds. dx dt is going to equal, this is going to go on the bottom, this is going to go on the top. So we get negative 12 root 769 feet squared per second in the top. And in the bottom we get 2 that's already there, and then this. 769 feet squared minus 625. What?
You want to simplify that?
Not yet. Does that make sense? So now what I'm going to do, 769 feet squared, 625 feet squared, we can subtract them, right? 144?
Mm-hmm. And then we square root that is 12, and then we times by 2, and it's 24.
So we get 144 feet squared, right? Feet squared minus feet squared is still feet squared. And then when we root it, we get 12 regular feet, right? (12 regular feet times 2 is 24 feet. Simplifying further, negative 12, 24. Both are divisible by 12, right? It's all multiplication at the top, so that becomes negative 1, and that becomes 2. Feet and feet, right? Feet squared becomes feet. Feet goes away in the bottom.
Seconds.
That's your answer.
Seconds goes down.
It doesn't really matter. If you really want, watch this. Units are on the outside now. And of course, x is changing at a negative rate because it's shrinking, right? Don't fear the root. It goes away. Not as bad as you thought it would be, right? But still not great because it's weird. These types of problems are weird. Do you see the setup though, right? You need to see that this is just a triangle, man standing on a dock. You need to be able to see, you gotta be clever, that dy dt is 0. There is no relationship between how tall how high his hands are and what the rope length is. And if you try to set up a relationship, you get the wrong answer. You get a bunch of nonsense. Yeah?
So what if you were to plug in 25 feet for y when you're doing this whole thing? Would it just like really screw stuff up?
You mean if you tried to figure out the relationship between y and r and you did this?
Well, if you already said, oh, I know what y is, you just get like r squared minus whatever 25 squared is.
You're saying plugged it in here?
Yes.
I mean, I did. What you can't do, right, is do this thing. Well, I need to find out what dy dt is, or be able to get y out of there before I do anything in my original equation, right? I don't want to get y out. If you try to get y out of there by setting this up and being like, oh, look, y equals 25r over root 769, so I'll substitute, right? No. They don't have this relationship because y does actually not change, right? R could change. R could be 5. And the relationship would still be the same. Y does not change. Or R could be, well, I changed the wrong one. Still, that's the idea. There is no relationship there. So don't try to make one, right? That's the idea. Someone check on Dylan for me. Okay, you good? All right. Get the salts out, right? We good? Do we understand why dy dt does not change at 0? Do we see why? Are we going to remember that?
No.
Dowd did from a month ago. Because y doesn't change. D means change. Y is the variable. 86, real quick. Same pouring from a pipe at a rate of 19 cubic feet per second. Cubic feet, right? 19 cubic feet per second. What rate is that, you think? Change in volume over time. If the falling sand forms a conical pile on the ground whose altitude is always 2/3 the diameter of the base, altitude is just height, right? So height is equal sign. Is means equals. Always 2/3 the diameter. We'll use big D instead of little d because little d means change. How fast is the radius increasing? So dr dt is what they're asking for, right? The change in the radius over time. When the pile is 12 feet high at h equals 12 feet. All right, well, if we took the derivative right now, we've got a problem, right? R and h. We're going to get dh dt and dr dt. Well, we want to know dr dt, so we're not going to get rid of r. And they've already given us dv dt, so we need to get h out of there because we don't want dh dt to pop up. H is 2/3 the diameter. So instead of using v equals 1/3 pi r squared h, we're going to substitute h for 2/3 d. And I think, great, I still have two variables, right? Well, what is d? 2 times the radius. So now you've only got one variable. Simplify. V equals, we've got 3 r's, so r cubed. 2/3 times 2 times 1/3. Ugh. So it's 9, 4, 4/9. And then we've got pi. 4139. Got it. Questions on that? Now you know what to do from here? Solve for dv dt, right? Take the derivative, dv dt, plug it in, blah, blah, blah. These are just coefficients, right? This one's not so bad. You want me to do it real quick or just move? Okay. Not so bad on that one. Just a thought. When I make this final, which will be tonight, I could put a bunch of problems on there, like how to do basic derivative, like what's the derivative of 2? What's the derivative of 2x? What's the derivative of 2x squared? I'm not going to put those on there. Right? There's a way easier way for me to know if you know how to take the derivative. Give you one of these, right? Or something from chapter 3. Because if you don't take the derivative, you're not going to do those problems, right? Like, you need those basic building blocks. It makes the final smaller, less time for you, right? The only downside is that you made all those easy giddy questions. But remember, for me, I'm going to take the easy questions, and that would have been on there. Right? We're assuming you got those. Because if you didn't know that, you're going to fail the stuff later anyway, and F is an F, right? I can give you 25 points out of 100 and say, here, I'll spot you these. If you don't know how to actually do it, well, then you shouldn't have got 25 points. But it doesn't matter, because you're still going to get 25%, right? That's an F. No one will get a 0 in this final. Okay?
This is what we're going to miss you.
But I think that's fair. I think I've said that before. Have I not said that? Okay. Like, you see what I'm saying? Like, it makes no sense to test stuff that's easy because the only way you get that wrong if you did know it is if you made a calculator error or did something dumb, a dumb mistake, which then I have to go look for and give you half credit on, right? Wasted both our times. Here's the point, they were free. If you didn't know it, well, you could fail finally, it's okay. So we'll probably start the final, the first question on there won't be really stuff from chapter 1. There might be like delta epsilon stuff, right? But I'm not going to ask you like, find the derivative of 2x squared, right? I might ask you to do it the limit process, but I'm not going to just like, here, here's a bunch of freebies, right? I'll give them to you, right? Save you time, save me time, everybody knows. All right, moving on to chapter 3.
Do you have like a general area of how many questions are going to be on the final?
Yes, the rule is if I can do it, okay, so for algebra, it's like if I can do it in an eighth of the time they can, because I'm really fast at algebra. For you guys, it'll probably be a fifth. That's what Walpole usually does. So if I can do it in a fifth of the time, that's fair, I think. So you guys can be 5 times slower than me. That's the rule, okay? I mean, honestly, number of questions is something you should really be worrying about. How many things is that question going to need you to do? Is it going to be 20 charts, right? See what I'm saying? It's not going to be 20 charts. Okay? It's not. But it's 17 minutes is a fifth of the time.
We get 80 minutes.
Oh, I didn't know it. Okay. Somebody's here. Cheer tryouts, or maybe it's AD Cup people. But that's the deal. Sartori, walking in the hallways. No, the school.